Welcome. In this video, I'm going to get you started on filling in the unit circle. So based on previous examples, if this is the unit circle, I know that this point here is 1, comma 0. This is 0, comma 1. So I'm filling in all the quadrantal angles first. -1, 0, and 0, -1. This angle here is 0 degrees or 0 radians. This angle here is 90 degrees, which is also pi over 2 in radians. Here we have 180 degrees, which is pi in radians. Now, those of you who have been watching the previous videos, speaking directly to those in my calculus course, you've seen that we've actually already looked at all of these angles and converted between radians and degrees, and we've even filled in these values on the unit circle. So that's what I'm getting you started on. This angle here is 270 degrees, which is 3 pi over 2. Now, this angle here in the middle, so starting in standard position there, this one's 45 degrees, and we looked at a 45, 45, 90 triangle to fill out these values of a root 2 over 2, comma, root 2 over 2. And again, this is 45 degrees. In radians, that's pi over 4. We also looked at a triangle up here. This forms a 30, 60, 90 triangle. This longer leg, which is the y value in this case, is root 3 over 2. And now looking at this triangle again, the shorter leg here along the x-axis, that's 1/2. And this is 60 degrees, which is the same thing as pi over 3. The last triangle we looked at was another 30, 60, 90 triangle, except it was oriented differently, making this x value the longer side. So this x value is the longer side, is equal to root 3 over 2. And the y value, which is this vertical side, is equal to 1/2. And this is 30 degrees, which is the same thing as pi over 6. So I'm going to help you fill out 2 more angles, and then I ask you to turn off this video and fill in the rest independently and use your best, do your best to use reference angles and what you already know. So before I help you fill out 2 angles, let's label the quadrants. This is quadrant 1, and in quadrant 1, x values, which are cosine of our angle, are greater than 0. Y values, which again can be represented as sine of an angle, are greater than 0. We move in a counterclockwise direction, so this is quadrant 2. And here in quadrant 2, x values are negative, so all cosines of angles here are less than 0. But the y values are still above the x-axis, and y is positive all up here in this section. So y, which is sine of an angle, is greater than 0. Next, let's look at quadrant 3. X is equal to cosine, and here cosine is still negative. And now since we're below the y-axis, the y values, so the sines of angles are also negative, so less than 0. And finally, quadrant 4, the x values, which are equal to the cosines of angles, are greater than 0. And the y values, which are equal to the sine of angles, still being under the x-axis, we know they're still negative, so less than 0. So let's use reference angles to find or fill in this information here. So now visually with a reference angle, you want to find an angle that's similarly at the same, that makes the same looking triangle here. That would be this angle here. Notice that this is 60 degrees. And if we travel in a clockwise direction, which is not normally what we do, this angle here is also 60 degrees. Please take a look at that symmetry. On that same note, here is another 60 degrees, and this is 60 degrees. So that means this angle, and this angle can all be found using these values. What I mean is, for those angles, your x value is going to look like 1/2, and your y value will be root 3 over 2 for every single one of them, and you only have to consider the signs. So let's work on this one. So I know I should have a 1/2 and a root 3 over 2. And now I take a look at this. Which value should be negative? It's not the sine one, that'll be positive. But the cosine one is negative. So let's go ahead and add that negative right here in front of that 1. Now as far as what this angle is, well, this is 90 degrees. Here is 60 degrees. What does that make this tiny little wedge here? If you answered 30 degrees, you're correct, and all of these add up to 180. So what we're looking at is 90 degrees plus 30 degrees. That gives us 120 degrees. Now, to convert this to radians, you want to multiply by pi over 180, and that will give you 2 pi over 3 radians. I will often count the pi's as fractions. This slice here is pi over 3, so this slice here is also pi over 3. You have two slices of pi over 3, making this 2 pi over 3. Okay, let's look at one more angle together. Let's look at this one right here. And let's figure out what its reference angle is. So I'm going to sketch an angle going this way. And you notice this is the middle of these three lines, so that means its reference angle is right here at 45 degrees. Now, if we're traveling in the positive direction here, this is another 45 degrees. If you're traveling in this direction, this is negative 45 degrees. So to fill in the x and y value, let's use these same numbers, root 2 over 2, root 2 over 2. And now consider which one is positive and which is negative. Cosine is positive, so it can remain the same, but the sign is negative, so this one needs a negative sign here. And I don't think I left enough space for that, so let me move it. There we go. Whew, that is tight. All right, that is about the best I can do. On your own paper, you'll find your own way to make sure that's written and looks like it's negative root 2 over 2. I'll write that in. Now, what about the angle? Like I said, we don't want to have a negative 45 degrees here. So let's consider this entire angle all the way around is 360 degrees, one revolution of a circle. And then we're looking at this negative 45 degree angle. So let's add that together. 360 plus a negative 45 degrees is equal to 315 degrees. Now, as far as radians goes, when you convert, this is 7 pi over 4. You can do this by multiplying this by pi over 180, or you can use the counting trick I showed you. If this is 1 pi over 4, and this is another pi over 4, here we have another pi over 4, another pi over 4, another pi over 4, and another pi over 4. And last one. How many pi over 4, let's say, pizza slices do I have? I have 1, 2, 3, 4, 5, 6, 7, making this 7 pi over 4 radians. Please stop this video now and continue filling in the remaining angles, both in degrees and radians, as well as the x and y values of the terminal points. I hope this video has left you merrier than a unicorn frolicking in a cotton candy meadow.